So good evening once again, everyone, and welcome to class. If you can see my screen, please just let me know once you can see my screen. I want to share the screen now. So tonight we are fantastic. So tonight we are going to be looking at the concluding part of the OSI model, TCP, IP model. So yesterday we looked at the OSI model and we said it comprises of 7 distinctive layers: the physical layer, the data link layer, the network layer, the transport, the presentation, the application. So 7 distinctive layer. And we also spoke about the different devices that works at each of these layers. That this is really important to our study, because that is absolutely one of the places that questions are being raised when it comes to networking or network engineering. So as a technical support engineer, it's important that we understand what are the uh, protocols that works in each of these layers. And we're going to have a better look at it tonight. So we're going to be looking at the second framework, which is the TCP IP. So we're going to be looking at the second framework tonight, which is the TCP IP model. So what is TCP IP? The TCP IP transmission, we call it the transmission control protocol. The transmission control protocol, internet protocol. So TCP slash IP means transmission control protocol slash internet protocol. Is a model that is another essential framework for understanding network communication. Remember that from our design or diagram yesterday, when we're looking at the 7 distinctive layer of the OSI model, all of this layer is a framework for communication between the client and the server. So remember that when we're talking about the kind of communication, we say we have the client-server model, whereby applications or services are hosted on a particular server and clients can go there to access the resources. So I can open up my web browser and type, www.google.com. There is a Google DNS server or server sitting at different locations of the world, and I will go there to fetch the information from the Google server. So we are saying that TCP/IP is also another kind of framework that is used for understanding network communication. However, unlike the OSI model, which has 7 layers, the TCP/IP model is composed of 4 layers. So these are just the things we need to pay attention to, especially when you're going to be asked questions in interviews. And most of these days, interviews are remote, online, whereby they can say, oh, what do you understand by TCP/IP and OSI model? One of the major differences is that, okay, OSI model has 7 layers, while TCP/IP is composed of 4 layers. They can ask you to then expatiate further. So these are the 4 layers of the TCP/IP network model. We have the network interface. This network interface is encapsulating or is bringing together both the layer 1 and the layer 2 of the OSI model. Is bringing together the layer 1 and the layer 2, which means the physical layer and the data link layer are joined together to form the network interface layer for TCP/IP. Then we have the internet layer. We have the transport and we have the application. The application is bringing together the three topmost. We're going to see more about them. But the next thing we need to look, it is the foundation of the modern internet and governs how data is transmitted across networks. It is the foundation of the modern internet. Remember that I said yesterday that one of the major purpose for ensuring that OSI model is designed is that every vendor must design their devices, must design their architecture, their infrastructure, their devices to meet a particular standard. So if a company says, oh, I'm starting to produce a switch, for instance, irrespective of wherever I deploy the switch, it should be working in layer 2. All right, so here is a detailed breakdown of each layer in the TCP IP model. So overview of it. The TCP IP model was developed by the US Department of Defense in the 1970s. Remember, like I said, nobody is going to be asking you for this, but if you know it, it's good. That it was designed by the US Department of Defense in the 1970s as part of its ARPANET project. This model is more practical and implementation focused compared to the OSI model and is used in real world networking system. So we are saying that the TCP IP model is just like the OSI model, but it's more of practical and implementation focused. OSI model is more of a standardization focused. Okay, this is the way we should do it. This is the way it should be done. However, this is the way it is being done. They are two different things. For instance, they will tell us in Nigeria, for instance, they will say bail is free. But is that actually true? When you go to the when things are happening and police, if you even go and report to the police to come and help you, resolve issue, you will see it boldly written in their office there, bail is free. But then there is something else that happens when you are now leaving. They say, won't you settle, guys? However, you told me bail is free. So OSI model is more like saying bail is free. But then TCP IP model is the real thing that is happening. All right. So, we're going to be looking at the layers of the TCP IP. We said it has the 4 layers in comparison to the OSI model. So the first layer is the network access layer, layer 1. And what is the purpose? It's still the same purpose that both layer 1 and layer 2 of the OSI model fulfills. That is what it's doing here too. The network access layer is responsible for the physical transmission of data on the network. For the physical transmission of data on the network. It combines the function of the OSI model's physical and data link layers. Please pay attention to this. You could have it in an interview. You could have it, maybe some of you that want to do CCNA, you want to do CompTIA A+, CompTIA M+, and so on. So understand that the network access layer is responsible for the transmission of data, and it combines both the first and the second layer of the OSI model. So we could see it here, the network interface, or which is the network access layer. It's both the first and second layer. And what are the functions? The first thing is data encapsulation. The function of the access layer or network access layer, it prepares data for transmission by adding a frame header and trailer. Let's go back to the diagram here. If you look at the network interface here, you will see Ethernet header and Ethernet trailer. Now, the actual data of the client or the user, myself or yourself, is this user data. But then you've added Ethernet header, you've added IP header, you've added TCP header. So these are the things that happens. So prepares the data for transmission by adding a frame header and trailer, which include the source and destination MAC address. Now, if you remember yesterday, from those of us that were in the class yesterday, we said in layer 2, the switch operates in layer 2 and it has what we call the CAMP database, CAMP, where it stores the MAC address of all the connected devices or users on that network. So when a user data comes into this layer, what it does is to add the source and the destination MAC address of the other user. So the second thing it does is physical transmission. That is, it handles the actual physical connection between devices. Remember that the first thing is, okay, it's still the layer 1 and layer 2. So this is where cables comes into play, including the transmission of raw data over cables, fiber optics, or wireless media. So another thing that happens here is media access control. It manages how devices on the same network segment gain access to the shared communication medium, e.g. CSMA / the CD in Ethernet network. There's what we call the carrier sense multi-access with collision detection. So what is this one saying is just like we are saying that if 4 of us are connected or 5 of us are connected to the same switch and we want to send out data. So there is a technology that wants to go and check, oh, is Mr. A sending the data? If A is sending data, it's going to tell B to still hold on. When A is done sending its data, B can now send. When B is done, C can now send. This is where the carrier sense multi-access with collision detection. So it's going to detect a collision. It's going to ensure that collision does not take place. So we still have the CSMA/CA avoidance. So it can help us to ensure we don't have collision on the network or on a segment. Error detection, it detects error that may occur during data transmission and ensures that erroneous frames are discarded. So when we say erroneous frames, erroneous is saying that things that are not correct or which are containing errors. So we move to the second layer of the TCP IP. Remember, we have just 4 layers. The first one is the network access layer. The second is the internet layer. What is the purpose of this internet layer? The internet layer is responsible for routing data Once you hear internet, wow, this is router. So it is our router or layer 3 switch that operates here. So the internet layer is responsible for routing data across multiple networks, ensuring that data packets reach their destination across potentially vast and complex networks. So we can see it green, the second layer here, and we can see that it has IP header, TCP IP header, and the data, user data that is being sent. What is the function of this layer? IP addressing. So assigns IP address to devices and ensures that each data packet has the correct source and destination IP. It ensures that each data packet has the correct source and destination IP address. So what are we saying here? We are saying that when we are sending a packet across a network, we must know it is the router that will let us to know that, oh, we have the right source or the correct source and the correct destination IP address. So the first thing that happens at this layer is IP addressing. Routing. There are some people whose job is just to subnet and allocate IP address to ensure that okay, IP address are not wasted on an infrastructure. Routing. It is this layer that determines the best path for data packets to travel from the source network to the destination network. So if for instance I am sending a file or a document from the HQ to a remote location. Okay, so for instance, today I have a job in the office. We have an office in Houston, and I work here in Lagos. So there is a VPN tunnel that we created between Lagos and Houston via Palo Alto, and successfully I was able to route traffic and use the tunnel and everything. And when we were done, they said, "Oh, thanks, Mayokun, for I wanted to remember now for." There's a way the white guy puts the grammar. If I get it, I'm going to check my mail again and But then the most important aspect here is it is the router that will determine the best route, especially if you are having maybe two upstream providers. So some of us now, you can be working in a place whereby you have two upstream providers. When we say upstream provider, we're talking about ISPs, maybe May1 and IPNS, and you configure load balancing. When we say load balancing, you are saying that you want to be using the two links concurrently. However, one is always going to be preferred. Maybe the latency on that one is minimal or the other one is faster. So it is your router that is going to choose the best path through which the data can be transmitted over the network. So routers operate at this layer, making decisions based on IP addresses. Router does not know anything about MAC address. All he knows is IP address, and that is what he used to make his decision. Switches are what knows MAC address and take decisions based on MAC addresses. Packet fragmentation and reassembling. This is another function or things that happens at the layer 2. Splits large data packets into smaller fragments to fit the maximum transmission unit, MTU. Sometimes you see this MTU configured as 1500 most times of the network. Then reassembles them at the destination. We explained this yesterday that okay, so when you send high volume of data, it's going to ensure that this is not pushed on the network at once to avoid uh, to avoid different to avoid too much load on the wire. So it breaks them down and gradually carries them to the destination. And at the destination, everything is reassembled and the user can view the data. Meanwhile, all of these things happens in a very fast medium that we cannot really say, oh, some people will say the internet is slow. It is the way it gradually gather those packets or those data and brings it into the format that we can understand. Protocols. What are the protocols that operate here? It includes core protocols like IPv4. We've discussed what IPv4 is before, and IPv6. And we know about ICMP. For instance, the ICMP protocol ping up here, address resolution protocol, actually works most times both in IP and in MAC address. So you can use your app to also check that in our switch. So we move to the third one, which is layer 3, transport layer. What is the purpose of having this transport layer? The transport layer ensures reliable data transfer between devices, handling the segmentation of data and managing end-to-end communication. We said this yesterday, and I think that should be our layer 5 yesterday. So that it's the one that handles the starting communication and ending the communication, ensuring that there is encryption and decryption. We explained all of this yesterday. So functions that takes place here is segmentation and reassembly. Breaks down large data streams into smaller segments or packets for easier transport across the network and reassemble them at the destination. This is what happens there. Flow control manages the rate at which data is sent to prevent overwhelming the receiving device or network. So when there is too much, so we begin to say, oh, there is the network is slow. Oh, I don't know, the network is dragging. So it is the layer 3 in TCP IP that ensures that packets are being delivered at the pace in which the receiver can receive it. Flow control manages the rate at which data is sent to prevent overwhelming receiving device or network. Okay. Error detection and recovery, that also happens at the layer 3. So ensures data integrity and detecting error. That's when we're talking about encapsulation and decryption. So ensuring that nobody has access to your data while you are sending it. Only the person you sent it to should be able to decrypt it. That is having the maybe public key or the private key that can be used to decrypt the information. So it ensures data integrity by detecting errors during transmission and retransmitting any lost or corrupted segment connection. So the next is connection establishment and termination. So it ensures, establishes and maintains and then terminates connection between devices. For instance, our TCP, which is the TCP, is used for connection oriented. That is, if we want to ensure that there is a reliable connection whereby we call it three-way handshake. The first thing is to, if I'm going to send any document to you or have conversation with you, I'm going to say, oh, hello, are you there? You tell me, yes, I am here. Then I will send you the first packet. But then, if it is our UDP, I don't care if you are there. The only thing is I keep sending. And if you are there, you keep receiving. So connection oriented is the TCP. Why the connectionless is where we use our UDP. The two main protocols at this layer, which is the layer 3, are TCP and the UDP. So TCP, Transmission Control Protocol, and UDP is User Datagram protocol for faster but less reliable communication. That is our UDP. But for a reliable communication, we use TCP. And the last one, which is the application layer, layer 4. The application layer provides network services directly to users. Application. It combines the function of the OSI model's application, presentation, and section. So it encompasses of the first 3 layers of the OSI model. And we can see it here, the application, it comprises of the section, presentation, and the application of the OSI model. At that point, we can just see the user data. What is the function? Application protocol defines the protocols that application use to communicate over the network, such as HTTP, that's our hypertext transfer protocol, FTP, file transfer protocol, SNMP, simple mail transfer protocol, and DNS, domain name system. So these are the things, the functions that the layer 4 performs in the TCP IP. Data presentation. It ensures that data is presented in a format that can be interpreted by the receiving application. So if I am talking French now, maybe 1 or 2 of us will only be able to hear me. But then, so many other people that should have access to my information will not be able. So it is the responsibility of the application layer to present data to users in a format that they can understand. User interface. It interacts directly with the software application, enabling users to perform tasks such as sending emails, downloading files, or browsing the web. And lastly, section management. It manages the section between applications, ensuring that data is properly synchronized and organized. These are the 4 major or the 4 layers of the TCP IP. So how did they compare? What is the comparison with OSI model? How does TCP IP compares to OSI model? The first thing we've said that, okay, OSI model is 7 layers, TCP IP is 4 layers. Number 1 is layer consolidation. So the TCP IP model has fewer layers because it consolidates several OSI model layer. If you look at it now, what is the consolidation? The first 3 layers in OSI model, 7, 6, and 5, are consolidated into 4. And 1 and 2 are consolidated into 1 in the TCP IP model. Once you are able to picture that, you already aced it. You already understand what is saying. Specifically, the TCP IP model's application layer includes the function of the OSI model application, presentation, and section layer, while its network access layer includes the function of the OSI model physical and data link layer. Then practicality. How do we practice it, or what is the physical representation, which I explained earlier by saying that, oh, if I go to the police station in Nigeria, we say that bail is free. However, when somebody is to be bailed, somehow they still collect money. So the TCP IP model is more practical and widely used in real world networks, especially for the internet, whereas the OSI model is more of a theoretical framework. So it's more of a theoretical framework. So we say, oh, it is just, and this is how it's supposed to be done. That is the theoretical framework. However, in real practice, we use the TCP IP. So we try to compare them. This is our OSI model: physical, data, network, transport, section, presentation, and application. And this is, so look at it. This is very important. So in physical layer, we know interfaces, cables, and fiber optics. That's what happens in our physical layer. And this is encompassing the network interface. So we've brought the two together now, comparing and contrasting them. So in layer 2, which is data link, we have Ethernet here, we have MAC address here, we have VLAN, we have point-to-point, P2P here. That is, we're looking at what are the things that operate in this layer. So in layer 2, because they can ask you what are the technology that operates in layer 2, the technology are Ethernet, MAC address, VLANs. You can configure VLANs, which I think is going to be our next class when we start configuring VLANs on a switch. How to configure VLAN to segment traffic. This is happening in layer 2. Some people's job, especially in ISP companies, is just to create VLANs, map the VLANs to a particular interface, map the VLANs to a switch interface, and so on and so forth. So we move to layer 3, which is layer 2 in TCP IP, but layer 3 in OSI model. What are the things that happens here? We look at IP here, we look at bispokes, we look at other technologies, Revenant, Dante. If there's anything you must pay attention to here is IP. This is what really operates at layer 3 and corresponding to layer 2 in TCP IP. Layer 4, transport, which is TCP, transmission control protocol, and the user datagram protocol, which are what is used at this layer. Then in the section SIP, SIP is for our VoIP, for VoIP, voice over internet, SDP, RTP. Then presentation, we have codec, we have SSL, and the major place I want to even talk about here is the application, IP audio, app, data, where this is where you begin to interact with the applications that are running on your system. Of course, as a network engineer, you should try to know everything, but the major part that is important to you is from the IP to the cables, fiber optics, and so on. Summary of TCP IP model. End-to-end communication. The TCP IP model focuses on ensuring end-to-end communication across diverse network, which is essential for the functioning of the internet. Then interoperability. In other words, by adhering to the TCP IP model, different devices, systems, and network can communicate effectively regardless of their underlying technology. So it does not matter which vendor. Once we follow the TCP IP model, they can communicate effectively with one another. Modularity. The model's layered approach allows for modular network design where different layers can be developed and improved independently. So you can go and develop a device to work in layer 1, and it will be, you can be designing that, another person is designing for layer 2, another person is designing for layer 3, and you can bring the 3 devices together and they will work to still carry out our networking activity. So this is just to compare them once again. Understanding the TCP IP model is crucial for us working in networking, as it underpins the functioning of the internet and most modern networked systems. The model provides a more streamlined and practical approach to networking compared to the OSI model, making it the backbone of today's digital world. I think that is the end of our class. Any question, please? So my intention is to ensure we don't have a prolonged class today so that we can conclude. Any question? If you have your question, you can raise up your hand. Any question? Hello? Can we hear me, please? All right. So if there's no question,
Yes, sir.
okay, thank you. I'm listening.
There's no question.
Oh, no
I'm just
question.
trying to respond to.
All right, thank you. Okay, somebody said I'm okay. Fantastic. All right. So if there's no question, thank you for coming to class tonight. Do have a wonderful night rest. See you tomorrow.
Yeah, thank you very much,
All
sir.
right, you're welcome.